Here we go. This is where it also starts getting fun. Now we have an nth root inside of an mth root. Now, again, we have to keep in mind that both m cannot equal 0 and n cannot equal 0. So when we see something like this, and this is raised to the first power, so if it's just kind of like saying just plain old a, so the nth root of a, well, I guess you'd want to say it, the mth root of the nth root of a. And that's going to equal 1 over mn. So for example, if we have the 6th root of the 3rd root of some number, let's have it be 2, then that's going to be 2 to the power of 1 over, your m is 6, times 3. So that's 2 to the 1 over 18th power. We can also see that this is true instead of just jumping straight to a form like that. If I have 3, the 3rd root of the 4th root of 2, well, if I look at this inside radical first, that's the same thing as saying 2 to the 1 over 4, right? But then I have to put it under this bigger radical, so now I have the 3rd root of 2 to the 1/4, and that's like saying 2 to the 1/4 times 1/3. So 2 to the 1 over 12th power. And I could take that straight from here. I can say the base is going to be 2, and I'm going to have 1 over m times n, so 3 times 4, that's going to equal 2 to the power of 1/12. Okay, this is similar to, they're all kind of similar to what we've been doing. We keep kind of adding on to the previous one. Now we have an exponent under the radical. So remember, this exponent under the radical is going to become our numerator of this fractional exponent. And again, you're just going to multiply your m times your n to get the denominator. So for example, let me try to choose small numbers so this doesn't get complicated. We're going to have the 4th root of the 3rd root of 5 squared. So our base is going to stay the same, that's 5. This exponent under the radical is going to become our numerator, so 2 over m is 4 times 3 is n. So that kind of looks like a jumbled mess right now, but our base is 5 and our exponent is going to be 2 over 12. If we want to simplify that fraction, it becomes 5 over 1/6. But we don't really need to worry about simplifying the fractions right now. Let's try one more example. If I have 5, the 5th root of the 6th root of 3 to the 4th power. Our base is 3. The numerator of this new power, the power that goes here, is going to be 4. Oh, you can't really see that. It's going to be 4. And then your m is 5, and your n is 6. So you have in the denominator 5 times 6. And so you're going to end up with 3 to the 4 over 30. All right, so now we take it one step further. So now we're taking the pth root of the mth root of the nth root of a to the c. So we just keep following the same pattern. But we need to remember that m cannot be 0, n cannot be 0, and p cannot be 0 because all of those are components of the denominator, and if any one of them is 0, then the entire denominator becomes 0, and this entire fraction becomes undefined, and we don't want that. So if we look at how this is similar to the previous one, remember in the previous one we just had m times n in the denominator. But now because we're also taking the pth root, that p is also multiplied to the denominator. So if we wanted to do an example, if I had that'd be some big radicals to fit all in each other, the 10th root of the 5th root of the 3rd root of 2 to the 6th power. My base is 2, that's easy, that just gets to go right there. This 6 is going to become the numerator, right, because we have this c and this c. So that becomes the numerator of the new exponent. And on the bottom, I'm going to have all of these numbers. So I have 10, which is my p, 5, which is my m, and 3, which is my n. And so this is going to become 10 times 5 times 3. That's a lot to say. But now we have 2 to the 6 over 150.